Hey everyone, and welcome back to this class, the Numpy stack in Python. In this lecture, we are going to look at one last common matrix operation, and that's how to solve a linear system. Recall that the form of a linear system is AX equals B, where A is a matrix, X is a column vector of values we're trying to solve for, and B is a vector of numbers. The solution is, of course, that we just multiply by A inverse on both sides. We're allowed to do that because we're assuming A is a square matrix, meaning that if it's invertible, then X has a unique solution. In other words, if the dimensionality of X is D, then we have D equations and D unknowns. So this should be pretty simple because we already have all the tools we need to make this calculation. You already saw how to do a matrix inverse, and you already saw how to do matrix multiplication. So those are the two things we need here. Let's do an example. So A is going to be 1, 2, 3, 4. B, I think we already have it. You know what, let's use 1, 2. So B is 1, 2, A is 1, 2, 3, 4. So the solution to this is X equals np.linalg.inverse of A times B. So the solution is 0 and 0.5. You can try solving that by hand to be sure. Now, of course, since this is such a common operation, in Numpy there is a better way to do it. It's a function that is appropriately named solve. So we call it np.linalg.solve. We pass in A and we pass in B. So we get the same answer. Now, if you've ever coded in MATLAB before, you'll notice that when you try to use the inverse method, MATLAB actually gives you a warning and tells you that there is a more efficient way to do it. It's not called solve in MATLAB, but it's essentially the same algorithm, and it is indeed more efficient. It is also more accurate. So if you ever have an equation like this to solve, you should never use the inverse method, you should always use solve.